Hello, hi. Okay, hello, hi. Can you hear me? Hello, hello. Yes, okay, cool. So let me grab you guys the check-in link real quick. Give me 1 second. On today's check-in link. And I think just for connectivity's sake, I don't think I'm getting the best connection today. So we're going to swap over to a better screen. Hello, hello. How's it going? Welcome to Learning Together Python 101 part. As soon as my computer chooses to work, we'll continue. So we're going to swap over to this. Okay, cool. Okay, now it's doing a tad bit better. Let me get some music going so it's a bit quieter. Let's do this. And then let's see. We can try this. Now let me see if I can get this working. Okay, so I don't think my camera's gonna work today, but that's perfectly fine. So we're actually gonna switch over to pure full screen mode, and we're gonna continue today like normal. But yeah, welcome everyone. Thank you for joining us for today. Where this is part 2 again of Python 101. So if you have not met, my name is Kev, and I'm a coach at Major League Hacking. I use the he, him, his pronouns, and I do a lot of different things. So honestly, feel free to talk to me about anything. Oh, right, the check-in link. Let me drop that in real quick. I cleared the schedule a bit because that's still partly work in progress. But let me give you guys your check-in link for the day. Hello, hello. Make sure you check in at that link below. So I'm actually going to skip through a lot of these slides because we've done a good chunk of the slides already. We're going to pick up where we left off from our last workshop. And last time we ended off with arithmetics. Oh my goodness, arithmetics operators. So today we're going to pick back up at assignment operators. So hope you're ready to learn some things about assignment operators. So the first things first is if you don't remember, we use Replit as our actual IDE engine. So this is the Replit we started last time. If you haven't started one, let me drop you a link for you to be able to start your own Replit. It's really simple. Once you create an account and you log in, you just create Replit and you select Python 3 as the Replit you want to be using. And once that is done, you can come back here and we will continue where we left off. And today we're going to go over a lot more examples as well as go more in depth into a lot more concepts. But to wrap up what we started last time, we're talking about operators that exist within coding and programming. So we talked about a quick, I guess, rundown of last time stuff, just so our new people are on the same page. Actually, I should have done this. So I'm going to start at the first slide. Or start here. So after getting started, but what is Python? Python is a high-level general purpose programming language. It's used in multiple things like scientific computing, data analysis, AI, or also for artificial intelligence, web development, so on and so forth. It was released in 1991. It's simple to use, great for beginners. It's interpreted language. We went over a lot of this stuff. If you want to go in depth, please look at the recording from last time. But yeah, it has large standard libraries for you to work with, so you can do many things. It has also a huge range of third-party libraries for you to build upon and also use their tools. So data types in Python. So data types, what are data types? Data types are just essentially a classification of data, and that way it can help determine the size, the format, and what type of data is allowed to be stored in it, as well as what operation is allowed to be performed with each type of data. We have numbers such as integers, floats, complex number, which you could actually use in Python. We have strings. After strings, we have booleans, which are just representation of two values, true or false. True or false values are known as booleans. We have lists that are a collection of elements, and they are ordered collection of elements. We have tuples. These are essentially the same thing as lists, but they're a order collection of immutable elements, so you cannot change a tuple after it's been created. We have set, which you will probably not see as much in Python unless you're doing things with set theory. But outside of that, for sets are essentially they're unordered collection of unique elements. So it's unordered and just every element has to be unique. Dictionary is one thing you probably use a lot. It's also known as hash maps, where having hash tables, maps, or associated arrays in other languages. For this one, it stores things in a key value pair, and it's also unordered. And we also talked about how to check for data type. You use the type function or method to check if what type of data a data is. Anytime, please feel free to drop a question in the chat, and we'll get those addressed. So getting hands-on, we did some data type stuff. So values are essentially just the data itself. For example, a value of integer would be 1, 2, 3. A value of Boolean would be true or false. A value of string might be that string hello that you see right there. A value of a list would be, for example, that list with either 1, 2, 3 in it, or banana, apples, etc., and so on and so forth. So values are essentially just an instance or the data of a data type. Then we went to variables, and this makes it a lot easier to explain. So values is what you essentially assign to variables. What are variables? Variables are essentially just a way to store value to a name. So it essentially names a memory location and allows you to store value to it, so you can easily access them as you are coding or use them later on in your code. We have assigning different type of values and variables. We went over how in Python, because it uses something called dynamically typed language, it doesn't matter. You don't actually initialize your actual variable as a specific type of container or specific type of variable. So for example, in other languages, you might say, oh, this variable can only store integers, and you wouldn't be able to store any other type of data type in there. But in Python, you can store, every variable can hold every value, and it will be dynamically determined what type of variable it is based off what value you have assigned to it. And there's pros and cons for doing so. And some of the pros, I guess maybe we'll try this. Some of the pros are just that it's really flexible and easy to write your code, because essentially you can start code, use same variables for different things, as well as you don't have to remake variables. So if I wanted to use like a counter, I can always use counter, or I can use a variable called temp, and that temp can be used throughout your whole entire program. The negative of that is that when a variable might be changed or reused, you would never know that it has been changed or reused. So for example, if I was using a variable that as integer, and later on I accidentally use that variable as a string, the parts that it was used as integer might not work anymore, because each different variable types has its own operation attached to it. But let's see. So we talked about operators. So really quick, there are a few categories of operators. You have never say this word. Arithmetic, there we go. It takes a while. Arithmetic operators, assignment operators, comparison operator, logic operators, bitwise operators, membership operators, as well as identity operators. We're gonna skip over the last three. We already went over arithmetic operators. We're gonna pick up at assignment operators. Then we're gonna do comparison, logical, and then we're gonna go on, continue, do some other cool things. So a quick review of the arithmetic operators. You have addition, subtraction, multiplication, division, floor division, and modules in Python. You also have exponentation, which is essentially just taking anything to a power. Then after that, we played a few examples of it. And today we're actually going to be using an actual Python file instead of just using the console. We're also known as an interpreter. We will go over that in a bit again. But real quick, so for the assignment operators, they're generally used to assign values to variables. You already saw one of them, and you're pretty familiar with just the regular equal assignment operator. The equal operator will just take the value on your right-hand side and assign it to the variable on your left-hand side. And we can take a look at that in action later. But we also built an easier way to do simple tasks. So for example, if I wanted to add something and then equal, instead of having to write the whole thing out and going, okay, I want to take that number that's already in the variable, store it, add it with something else, and store it in the same variable, we can shortcut that by using things such as the plus equals, minus equals, multiply equals, divide equals, floor division equals, or exponential equals. We'll go into more examples how to use them. Essentially what it does is it takes the left value and adds to it the right value, where it takes the left value, subtracts it, the right it takes the left value and it adds or subtracts to it, where it performs the operation based off of what is on the right side, and then it automatically assigns it back into the variable on the left side. So it's a really nice way to simply shortcut longer statements of expressions into a smaller, more condensed versions. We also have and equals, or equals, as well as XOR equals. So later, we're actually going to skip this in for here, but if you ever see these, you understand what they are. So and equals, essentially, it is what something we call bitwise and. Essentially, we'll perform the bitwise and operation and then store that. And same thing with or will perform bitwise or and then store that, with XOR being performing bitwise XOR and then storing that. The last two are essentially just shift operations. It does some bitwise shift. Just make sure these don't look foreign because they're pretty common assignment operators. But the real ones you really genuinely see is a lot of plus equals, minus equals, maybe even multiply and divide equals, but that's really it. Maybe you see a bit of modulus here and there, but everything else on this list is pretty rarely seen. So let's look at some assignment operators. So, like I mentioned, so we also did talk about last time expressions already, but like I mentioned, so let's start with writing a version of this, right? So we talked about how variables work. So I'm going to make a variable call, let's say, a, right? So I'm going to work with mathematical equations because we're talking a lot about assignment operators. I'm going to stick with variable name a. I'm going to set that equal to 0 for now. I'm going to set a variable to name b. I'm going to set that also equal to 0. I'm going to make a variable named c and set that to 0. And then let's see. Let's build out some of these variables. So let's say a is going to be 7. B is going to be 9. C is going to be, let's do 23. So, for example, if I want to make a variable called sum, what I can do is do sum is equal to a plus b plus c, right? So you can see that the addition and the actual assignment operator is completely separate. And if I run this, we're going to do a really quick detour. Actually, that reminds me, I do need to teach this before we can actually use this. So there is a function in Python called print. Printing allows you to output something to the terminal so people can actually see it. And the reason I need to introduce this real quick is if I can't print, you wouldn't be able to see the result of the answer here. So after that's all been summed up, we're going to do print. And let's say we're going to print sum here. And you're going to hit run. So you can see that it's running and it printed what sum was. And it says sum is equal to 39. So as you can see, how this works is it summed up everything, then it does assignment. But what we could also do is do it like a running sum. So for example, I'm going to come down in here. I can do sum is equal to, but instead of equal to, I'm going to use the assignment operator of plus equal. I'm going to do sum plus equals 7. What this is going to do, it's going to take whatever our variables in sum. It's going to add 7 to it and then store it right back in the sum. The other way to write the same exact statement is to do sum equal to sum plus 7, right? So you can see how that's a lot more to type, and it achieves the same exact thing by just taking sum at 7 and stores it back. This condenses it saying, okay, I want you to take the variable sum, add it to 7, and store it back into sum. So if I do this and I print out sum, you can see that sum has been modified and changed. And now you get 46, because 39 plus 7 is 46. So that is example using the different type of assignment operators. We can use another one, for example, if I wanted to figure out what is that divided by, whatever in sum, I want to divide it by, let's say, 5, and then store it back in the sum. I can do that. And then, for example, I'm just going to write a print statement again, hit run, and you can see that it did that and stored it back in the sum. So now whatever after the mathematical equation is computed is what is stored currently into sum, or the variable sum. Okay, so that was some assignment operator stuff. I'm going to proceed forward. Now we're going to talk about some comparison operator, and this has to do a lot more with Boolean values that we kind of talked and touched upon in our first workshop. So with Boolean values, with comparison operators, they're generally used to compare values of two variables to expression. If you don't know yet, expression are essentially what makes up majority of what you do in Python. So writing anything that expression could be also a simple expression or a complex one. A simple expression could just be a single variable. It could be a simple data. point. Well, a complex one could be like all the arithmetic operations we computed, and all those arithmetic equations are also known as expression, because for more complex expressions, what it should do is it should sum up everything and condense into one final answer. But yeah, so for some comparison operators, we can see here that we have a few of them. So equal to is like when you generally do it, you actually probably seen a lot of this in mathematics already. Equal to means equal to. So if I want to compare one thing to another thing, I can use equal to make sure they're the same. If I want to say I want to make sure these things are not equivalent, I can use not equal to. And if you don't know, in computer science, we use the exclamation point for not in a lot of cases, which just means negation, or also means I guess negative. But you can see that if actually for a funny lore, if you guys stick around for a lot of Glow Hack, we run a workshop or a mini event called No Light, and we use not light is what we write it as, and it's a pretty funny thing. So instead of just putting actually no light, we just call it exclamation point light, and that's why the exclamation point is there because it just means it's not light or not equal to. So then we have your common ones such as greater than as well as less than, and then we have greater than equal to or less than equal to. So these are really common comparison operators that you might use in everyday logical problems in your life, and they also exist in Python that can be used to write more complex expressions in Python to be able to achieve stronger goals. So let's look at some comparison operators real quick. So we're going to hop back over to our replit. We're going to go into the shell this time, actually. So for example, if I asked the interpreter if it's 5 equal to 5, which I'm saying is 5 equivalent to 5, it will then take that, process it. Oops, I meant to go into, oops. Let's clear that. I forgot. Whenever you get into the shell, you do need to write on 3 to actually get into the interpreter. So now if I do 5, it's 5 equal to 5. It'll say it's true, right? Because we know for a fact that 5 is equivalent to 5. If we did 5 is equal to 10, it'll go false because we know that 5 is not equivalent to 10. And then from there, another example is we can use the not equal sign, right? So if now I say it's 5 not equal to 10, you can see that this returns true because 5 is indeed not equivalent to 10. But if I can also, in the same scenario, do 5 is not equal to 5, which this time it will return false because 5 is equivalent to 5. And then we have other ones we have looked at. So let's play around with some of them as well. So for example, we can say is 5 greater than 10. We know for a fact 5 is greater than 10. I can do is 10 greater than 5. I'll say 10 is greater than 5. I mean, let's backtrack that. I just said 5 is greater than 10. 5 is definitely less than 10, but we know that 5 is less than 10. So that is false. But 10 is definitely greater than 5, so that's true. And the rest of that is pretty self-explanatory. And for this is we can use it to build more complex expressions, right? I just only built simple expressions. So for example, to make this more of a complex expression, I can do is 40 greater than 50, and then is 50 less than 40. If you did this, it would say false, because this will evaluate from the left-hand side all the way to the right-hand side, and then if you do is 40 greater than 50, you will get a response, and then the response will then be compared with 40, which is false, less than 40, which is not even true. So I'm actually going to clear this real quick. And then when we actually get to conditional blocks, you can see why conditional operators becomes really important, but that is some example of how they're used in Python. So let's move on past conditional operators. We're going to look at our logical operators. So these are equally as important. Wait, did I mess that up? I did comparison. Where's my logical? Oopsies. I guess I forgot an update for the logic operators, which actually, let me check if that even matters. Let me think. No, we're going to move on without doing the logic operators for temporary right now. And then let's going to move on to expressions, which we've done. So from there, we're going to look at actually, so question, and then we're going to actually swap over to here to continue. So now we're going to work in our actually a Python file. So I'm going to clear this. So if you want, you might see your screen that looks more similar like this. Once you've created a replit, what you want to do is now click on the plus thing for a new file, and then just name something, for example, Global Hack Week, games.py. So if I hit enter, I'm actually going to just delete this because I'm not going to use it at all. So I'm just going to delete it. Yes, delete. Okay, cool. So now we have Global Hack Week games.py. So we're going to need the console. So I'm going to actually put the console below and split our view so we can look at more than one things at once. So actually, I want my console below, actually. Then let's put the shell with the console because I don't want to take any more space than we need to. Okay, cool. So we can write the code on top and hit run and see it print at the bottom. We can then now close out this as well because that's no longer needed for now. If we do need to bring that up, we can bring that up later, but that's gone. We don't need that. So now we're going to actually start going over some pretty important concepts. Let me get this sorted properly real quick. Okay. Whoop. Sorry, there's a little lag. Give me 1 second. Okay. Cool. So everything should be good. I'm just waiting for my streamer to catch up. Okay, there we go. Okay, cool. So we're going to start off with learning print statements, and printing statements are pretty common across multiple languages that you might work with. Wait, sorry. Give me 1 second. Let's see. Does everyone have an interpreter or a replit up yet? Okay. So first thing is, the first thing that when you take any computer science course or any language, the first thing that you choose is how to print. So in Python, the print statement in Python is just the word print itself. So you just do print, and then you would pass it in generally a string is where you're allowed to print. You can also print variables. You also can print numbers, etc. So you would just pass in print. You can then the most common things people print are strings. And one of the most common strings that in every language you learn print initially is hello world. So we're just going to do that real quick. Sure that this works. So we're going to do print space hello world. And then after that has been done typing, all you got to do is run it. And now you can see if you look at your actual console, when you run print hello world, the console will then respond and print out to the user hello world. Okay, well, oh, because it's still trying to print from that. Okay, so that's a whole nother problem. I need to configure this to be what is being ran. Give me 1 second. Let me fix that. Tiny technical mistake. I should not have deleted main.py because now your run button is defaultly programmed in to run with the main file. So I actually need to go down to settings essentially and change them manually. So first thing first, I'm gonna click on the triple dot. And then click on show hidden files because they hide that file. So I'm gonna go to replit. The .replit file is your configuration file for your replit. Oops, it's too high. Let's see. Okay, cool. So once you're in your .replit file, well, that's the wrong one. Okay, once you're in your .replit file, you're just going to change run to be whatever file you want to run by default. So in this case, I'm going to do global hack week games.py. So now once that's been saved, if I hit run, it should work fine. Oops, oopsie daisy. Let's see. Why did that fail? Let's see. .py, oh, games, global hack week games.py. I'm gonna copy this and put this on endpoint as well. So let me throw that in here. Then cut back. Oops. Let's see. You can figure. Try to add dark. I did. What do you mean run is definitely configured? Oh, there we go. Okay, it just took a second to fix itself. There we go. So now if you hit run, it actually runs our file that we custom named. And then we can close this out. Okay, cool. So that is printing. We just printed out hello world, which is one of the first things you learn how to do. And then let's now go over some of the cool things we can do. So first things first, we're actually going to go over conditional statements. So how a conditional statement works is you write things in generally if, else, else if blocks, or you put the else if in between, but you could technically have an if block without an else if. So we're going to first write an example of that. So now we can print. That's great. So let's do the next thing before we even consider conditional. What's the most common thing you can do after you know how to print is you would take input from the user, right? So for example, this will be important, especially for our third workshop, or we're actually going to be building a text line game or a command line game or a command text line game. I don't know what you want to call it. But for us, actually, let me see. I kind of want to fix my camera. So this is, unfortunately, that's not working, but that's okay. Okay, cool. So we're going to do input. So to take input from a user, right, we already figured out how to print out something to the user. So we have figured out how to show the user something. Now let's figure out how to take an input from the user. So in Python, we have a function called input. And what input does is you provided a prompt, generally in a string, and the input will then prompt the user with whatever your prompt is. So for example, name, right? So my prompt is going to be name. It will prompt the user, and then it will return as a string. But if you see I don't know if anyone currently sees the problem we're actually facing right now. If I do this, if I run it as is right now, we face a problem, which is if I run and it says hello world, ask me to input my name, and let's say if I Kev, and I hit enter, that terminates the program. But not even necessarily just that, I don't get anything out of it. So for example, okay, if I just wanted to print out what I got, I would just do print, and I can do print input. So what this would do is it'll first ask print out hello world, then it'll ask the user, hey, can I get your name? Then I'm gonna put Kevin, and then what it does is hello? Did I not do this right, Kev? Okay. Maybe I am, wait, if I do Kev, yeah, there you go. Okay, so it's broken for a second. That's fine. So as you can see, it then took the input and then printed out Kev, right? So this is hello world comes from line 1 where we printed. Line 2 where we did input is what the name is printed. The user entered Kev, and then because we told them grab this from the user and then we'll print it out, we print out Kev, right? But this is useful, but not really, because you don't get a way to use the input. You only get to print out once. Also, hello, Bread Bee. Welcome. We're doing our second day of workshops on Introduction to Python. But yeah, so you can see that that's really not useful. But what is one thing that we already learned that could be really useful to be able to handle this, right? So what that is variables, because variables allows us to store this input to be used for later. And we know that this input always comes as a string. So input is always in the data type strings. And if you think about it, it logically makes sense, correct? Since the user is what's feeding you something to the console, so you can just imagine the user is hitting a lot of character. It goes into the computer, and then there's computer. I don't want to go into too technical details, but then the computer just reads it as a group of characters, which is just a string. So I'm going to make a variable. I'm going to call it name. I'm going to set name is equal to input name, right? What this allows me to do is then later use name for other purposes. For example, if I want to figure out what type name is, I can do type and then do name. Well, capitalization matters, so I'm going to put the cap in, and I can do to see it now because we're no longer in the interpreter, so we will have to add print. So it actually prints the console so we can actually interact and see it. Hit run. Now you can see the first thing that's going to happen is it's going to print hello world. We're going to get a prompt. For the prompt, I'm going to respond with bread underscore bees. If I hit enter, you can see it told me strings, right? So what it does is it took the input from the user, stored it in the variable name, and then later when the code referenced name, what was stored there is the string that was from the user, which in this case it was Kev. And from there, we can build more complex print sentences. Now we're going to revisit print. And okay, yeah, printing one word, one variable is okay. But what else can we do? So what we can do is make more complex print statements by adding multiple variables and multiple strings together. The first things first is maybe I can say my name is, and then from here, there's 2 or 3 methods to do it. We have one thing called string concatenation, which is when you use a plus sign. String concatenation is done when you use when you put plus signs between more than one strings. And what it does is then it joins both of the strings together. The only issue with string concatenation, as the name implies, only works for a string. That means you cannot add numbers to it. You cannot add other data types to it. All you can print out, you can join together as strings. So, for example, in our case, if we wanted to add name to it, and then if I run this, you'll see what I was talking about. I can do my name is Kev, and it goes my name is Kev. As you can see, how this works is just takes wherever the string is and then adds it to the string. And you saw how there's no space here, and the reason there's no space here is because we don't have a string space in this string, and there's no space in the string because the user didn't input a space before they hit enter. To fix that problem, all you gotta do is just add a space here, and then now if you run this, because legitimately all it does is take one string, takes another string, puts the beginning of that one string at the end of the other string, and then you make a huger string. So now if I do this, you can see that now there's a space set in there. And the other method, what we're talking about, which allows you to actually mix a lot of data types, not just only work work only with strings, is using commas. Comma is print statements a natural delimiter for different values, so it is a lot more powerful. For example, if I do a name, and let's say I want to get something else from the user, I want to ask for age. So I'm gonna do age as input, and then I'm gonna do name. Age, right? So I'm gonna do that, and then I'm gonna hit enter. So you'll see a thing real quick. So if I do, I'm gonna leave it back with string concatenation and show you how this can work fully before you do something else. Up, reload. The internet doesn't like me right now, I guess. But yeah, so if I put name there and then I do another plus and then let's say I'm gonna do a period here, so I can add that to the end of name, right? So the user's not gonna put a period there, but I want it to be a period. So then we're gonna do another quote, and then from here, my name is name, my age is, and I'm gonna hit enter because it doesn't automatically default do that, and I can do add age. And if I run this, I can do my name is Kev, my age is 100 years old. If I hit enter, you can see it builds the whole string out saying my name is Kev, my age is 100, right? Isn't that weird though? Because age, we entered 100. Shouldn't 100 be a number? And I just contradicted myself in saying, oh yeah, it prints string concatenation only works with strings. And the reason is, like I said earlier, to highlight my point, is that inputs always come in as the type string. And to prove that point, if I did a type on age, and I do, you can see the age. Oh, I forgot to hit print. Remember to do that. if you're actually working on a file with a console, you need to hit print. Let me try that again. Oops, that was a mistake. I'm gonna do Kev, I'm gonna do age 100. You can see 100 is still a string. To convert something, we actually do something called typecasting. And that's the next concept we're gonna introduce. So for example, I want age to, let's say, be a number because I want to be able to do math with it later on in my equation, maybe to calculate someone's birthday or birth year from the current year, or et cetera, et cetera. And from that, we want to be able to do an operation we like to call typecasting. What typecasting does is it takes a data type that is eligible or is is allowed to be converted to another data type to to return a different value. For example, numbers numbers are just characters to a computer, so it could be represented as a string. But on top of that, numbers can also be represented as integer to be used for mathematical operations and so on and so forth. So to typecast, all you gotta do is add the type's name. So you can see it's a built-in string. You can see it actually just automatically popped in. You add in the type name you want to cast it to, and then you surround that with the object you want to, with the data or with the value you want to cast it, right? So what it's saying is take an age and then typecast it int. And the reason why I say this is really important is because now if we typecast it as an integer, there's some values we no longer can accept, right? For example, if I gave it a string, typecast didn't know what to do to cast it to integers. So let's test that. So first thing, I'm going to use this properly and show you why this breaks our code here already. So if I do name, you can see that is the class string. If I do age and I do, let's say 100, you see that breaks. Because you can only, this is really important to actually learn and be able to understand and read errors, because that'll be super beneficial for as you're coding to be able to go through and figure out what you did wrong. So the type error tells you that this is a type error, which means you are using an operation for a specific data type with a data type that does not support the operation. And for this case, you can see that print my name is name, my age is age is what actually caused this error, and it tells you why. It says can only concatenate strings, not integers to strings. So it knew that now because I actually typecasted this to int. You can see that the class of age is now integers. We can no longer do concatenation, and this is where the other natural delimiters in print comes along really handy. Is I don't need that because I can just use commas. Commas will naturally help me combine values and variables together or expressions together so they can be used. Oops, I took away that. They can be used in print statements. For string concatenation, it's not solely limited to print statement. It has other functionality where you can use string concatenation. But for our case, we're just going to build this out real quick. I'm going to do a comma, hit space, I'm going to hit run, and you can see that now, this time, I can do I can do age is 100, and this time you can see that the print statement will now work because I use the commas, which are supported by print itself. So it's essentially, all you guys think of is concatenation is string only. It's an operation that only exists for strings, and it exists outside of printing. So there's other reasons you might want to use concatenation. Well, printing using the comma delimiter is actually built in only for printing, where you can use commas to print multiple objects of different data values or data types. Okay, give me 1 second. Okay, cool. So now we have done that. Let's see, sorry, that threw me off for a second. Okay, cool. So print my name is name, my age is age. And so now we know how to typecast now to get information from the user. We can now look into more complex things to do. Let's see. I need to just really quickly remember what else we got slated in. We've been over values, expressions. I made a quick list of things I want to cover. We went over casting, so let's do some basic, simple decisions and logic, right? So in Python, we have something called conditional blocks, which are if. And so, for example, if I want to ask an additional question, but only if the person's age is greater than 21. So for example, I'm going to write an additional question so I'm going to call it input. I'm going to call it drink choice is equal to input. What do you want to drink? Question mark. And then let's say right now anyone can actually I'm gonna take this out. So I'm gonna make this more like a natural flowing conversation. So let's reword some of the stuff. So we can still take input. Let's take this out, and then let's make this cool and fun. So I'm gonna take a lot of this out and then rewrite some of the stuff real quick. So we're gonna do the top. We're just gonna do print. I'm gonna do print, and we're gonna say, hello, welcome to the tavern. I can't spell. I don't think that's how you spell. V-E-R-A-N. Yeah, tavern. Okay, welcome to the tavern. And then there's actually we're gonna learn a few things real quick. Actually, building this allows me to teach you how to use escape sequences. So escape sequences, essentially, there might be special characters. If, for example, N by itself is just a letter N. But if I do a \n, well, this is the escape sequence for a new line. What escape sequence basically allows you to do is allow you to use specific already designed or dedicated thing that in a string would normally be read as string to be read as the actual. You can think of it as a command or as something to process, right? So, for example, if I just leave it like this, if I just type N, what this does is just adds N to the string. If I do a escape sequence N, it's telling it I don't actually just want to add the N, I want to add a new line because \n is the escape sequence for a new line. So I could write multiple print statement where I can use the new line character just to have it automatically generate a new line and then write more to it, right? So hello, welcome to the tavern. What is your name? Right? So I can build it like this. I'm going to do a new line again. So there's space between the input text, and then there's a space between, so it's like a game, right? And then after that, maybe like, then maybe I can do another print statement, right? I can do like, oh, nice to meet you. You see how like we're naturally going to start using. So like, for example, nice to meet you. And then we can insert their name, whatever they told us here. Nice to meet you, name. How can I help you today? Maybe I say, maybe instead of that, we can do, would you like a drink? And then, let's change this up. So what would it make sense for someone to ask their age, right? So like, would you like a drink? And we can do, okay, actually, this is probably really good. We'll build in some conditions here. So we'll learn how to do conditions. So like, if they don't want to drink, you don't have to know their age. If they want to drink, you want them to have to know their age, right? So we're gonna build a new thing and be like, drink, yes, no. Don't mind my variable names. We're gonna go over better variable names than what I'm doing. And also in Python, we have, well, actually in computer science, there's generally two ways of naming variables. We have variable names, what we call camel case, with variable names, what we call, not variable names, variable naming conventions, what we call snake case. For camel case, what you essentially do is you always start with a lowercase letter. And then let's say if I do found, and for each new word, instead of using space, you would do capital letter. And that's what found now the plate. Right, so each new word that you would normally put a space between, you would just capitalize the letter in front, and this is how you can be able to read that easily. Snake case is done like this. So I'm going to actually put pound. So pound with $sign is how you generally leave a comment in Python. So for example, for snake case, I would do this, or, so this is in snake case, instead of using capitalizing the first letter of the new word, after the space, you will just use underscores. So the snake case version of the same exact variable name is this. So you can choose either one. In Python, the general convention is to use snake case though over camel case. So there's like pseudo conventions within the language you might be trying to program in. For example, I think in C++ it is generally camel case and so on and so forth. But yeah, so let's go back to so drink, yes or no, right? So I am essentially trying to figure out the variable name here to make it really obvious what's stored in here is this stores the answer to the person's wanting a drink. So actually, I would probably now, because I want to ask a question and take an input, instead of asking it here, I would probably abstract this out. I'm going to take it out. It's very nice to meet you. And if you want exclamation point, you have to use this. So I just did an exclamation point there. So now I'm going to go down here. I'm going to do input to see if they want a drink or not. So I'm going to do input. Would you like a drink? Then, oops. Oh, I forgot. So it's yelling at me because I lowercased it. So I need to lowercase everything that's using it. So now if I run okay. So now if I run this, I think this should work fine. Would you like a drink? And so the biggest issue is like, if we don't want to drink, maybe we don't want to say yes or no. So I can do, my name is Kev. Oh, nice to meet you, Kev. Would you like a drink? So I probably, because of how this is done, you probably want to use string concatenation. Actually, you can actually mix and match them because again, string concatenation exists outside of this. So I can do like Kev, and you can do nice to meet you, Kev. Would you like a drink? And then you can see that it's not nicely put on the next line. So if I want to nicely be able to answer this question next line, just to format, I can add a new line character there or a new line escape sequence. I'm going to do Kev. Would you like a drink, Kev? I can do yes. And yes, it asks me my age, which makes sense, right? So let's say I'm going to put 18 in for now. It's like, what would you want to drink? Well, number one, we have a few problems here. If we're only 18, I don't think we want them to be getting a drink. And if they said no, we also don't want them to be getting a drink. So let's say I'm going to go back. And this is where conditional becomes in really handy. So I do Kev, and you say, well, would you like to drink? I put no. There's no reason for them to ask me my age. So I'm going to go in here, and this is our first conditional. Conditional blocks or logic works with conditional operators. So for example, here, I can go only ask age, because if the person wants to drink. So I do if drink yes no is equal to, which remember we talked about means it's equivalent to the string yes. And then so in Python it is known as a syntax-based language, which means your syntax is what determines how the interpreter actually interprets each line. And it's not non-scientific knowledge like C++. Java might use things like curly loop braces to determine the start and stop of a line. So that matters. I mean, example, you can see the age is yelling at me because there's technically nothing tabbed into if, which means like whenever if I tap this in, it's essentially nesting this statement into the if, meaning that if this is true, it will then go into its nested statement going, okay, if it is true, ask for its drinking age, right? And the biggest thing is, I'm going to run this. So for example, so my name is Kev. Now if I say, would you like a drink? Say no. It's still currently asking, what do you want to drink? We're going to fix that later. But if now you saw it doesn't ask you for your age anymore, but I'm going to change this to Kev. What would you like? Would you like a drink? If I do yes, you can see it now it asks you for age. And let me say maybe my age is 80. And then it asks you what you want to drink. But now the problem is, what if 80 you could get a drink, but what if you're younger than 80? So we want to build in more conditional statements, right? So I'm actually not going to do that. What I'm going to show you is we have also something called nested conditional statements. What that means is essentially only when the first condition is true, you might want to check a second condition. For our case, maybe we want to get the age only if they want to drink, and then after we get the age, we only if they want to drink, we want to ask for their choices, right? But let's say I'm gonna write something in between, so I can just do this and then be like age, and maybe I now want, if I do this, right? Even though it's nested in, so what makes this good is previously you saw even if I said no, I don't want to drink, it still asks me my drink choice. But now if I nest this in, and oops. Now, since I lesson in, if I do, would you like a drink? If I say no, it no longer asks me for a drink choice. Now, both of those statements, or it's both those inputs from the user are now nested under the if statement if I want to drink, and it's not yes. But that poses a problem, because what if I am not legally able to drink yet? So I want to ask you for your age, see if you're legally able to drink. but I don't want to ask you to drink choice if you're not old enough to drink, because there's no point. Or maybe I want to modify it so like if they're old enough, they say something. If they don't, so we're gonna do that as an example, right? So if I do Kev, let's say, would you like a drink? I say, yes, I would love a drink. My age is 18. You shouldn't be prompting me for a drink, or maybe you should be prompting for a specific, right? So would you like a, let's do like alcohol, whatever, I can't spell, but you get the point. So I'm gonna run that again. So would you like to drink? My name is Kev. Oh, nice to meet you, Kev. What would you like a drink? Yes, please. But the age of 18, it says, would you like, if you want to drink, if you want to, that does not make sense. What do you want to, what alcoholic drink do you want? Okay, I have to reword the sentence because I messed it up. Don't mind me. Enter. Oops, oopsie daisy. Hit enter. And then I'm going to paste this right in. Okay, cool. So there we go. So now what we'll do is what I was talking about is what we call a nested conditional statement. So after the input of yes, maybe inside here, I would want another check, right? So I don't really want to ask them if they, what alcoholic drink they want if they're not over the age of 21. So I can do if age is greater than or equal to 21. And you saw here, I don't use a string because when I took the input from the user, I made sure I typecasted it to integer, so I could do this integer comparison between numbers. So if age is greater than or equal to 21, you can ask them input what alcohol drink do you want. So let's run this. So let's look at the starter. So your name, okay, my name is Kev. And then let's see. Oh, nice to meet you, Kev. What would you like to? Would you like a drink? Yeah, I would like a drink. Okay, cool. Age. Oh well, I'm only 18. But you see, the problem here is that if I'm only 18, it doesn't say anything. But let's see the other condition. So, what's your name? My name is Kev. Would you like a drink? Yeah, I would like a drink. If my age is, let's say, 21, because he now asks you, what alcohol drink would you want? And I can say like, I don't know, a beer. Right, and now beer stored away. So we saw now we have two nested. So let me just do this. I think this is probably better. Yeah, there we go. So now you saw that there is two nested if statements, but now we talked about how if statements are made more than generally just ifs. If conditional blocks are made of three different components. We have if, we have elif, which just basically stands for else if, and then we have else. So all this works is if your first if statement triggers, then it's all great, you're done. If you have more conditions than one, and you want to check them one after another, you put, let's say, if I am 21, if I'm older, 21 or older, get me an alcoholic drink. Or ask if I want an alcoholic drink. If you have another condition, like you can do if, you can do else if. Else if I'm less than 18, give me, ask me for a soda or something. And then you can do else, which will catch everything else. So the whole point here is if is your first conditional thing you want to check, and if conditional blocks, check them in order you list them. So if you have multiple things you want to check one after another, so if something is not true, you want to check something else, you can do if, else if, else if, else if. And then whenever you're done, if there is something you want to run, if all of those if statements fail, you would use the else statement. Let's see. So for example, now maybe if you're not older than 21, maybe I want to ask you for a soda. But maybe I only want to ask you for a soda if you are older than at least 10 years old, right? I don't want to get someone who's under 10. Okay, maybe we'll make it. If you're older than 6-year-olds, right? I don't want to give anyone under the 6-year-old soda, so maybe I would do if age is greater than or equal to 6. And then we can use we can copy this down, and then you can just give a different prompt, right? So what soda do you want? And now you might be wondering, wait, we currently have the first statement going if it's greater than equal to 21, but if it's still greater than 21, it's also greater than equal to 6, right? This is the reason why we have conditional blocks with elifs in it, right? So only one of them can run. So either if runs or elif runs. So you want to put your stronger check, more precise check at the top. And then you want to put your weaker check as it gets more generalized in general at the bottom, closer to your else. And your else is your most general one, right? It's saying if all of those fails, here's what you want the else to run. So for example, if we do if age is greater than or equal to 21, you can ask what alcohol drink. Now it's saying if that's not true, you're not older than 21. If you're at least older than 6, we can ask you what soda you want. Let's write another one, right? So let's say if your age is at least greater than or equal to, let's say 0. Well, you can be 0 years old. Equal to 0, we can ask you let's see, what do we want to ask? Let's ask what between milk and apple juice, what do you want? Question mark, right? So now we broke in 2 elif cases. One, first we are you 21 or older? It's the most specific case. Oh yeah, no, okay, great. Are you at least 6 years and older? Oh, okay, you are. Okay, you want a soda. If no, okay, great. Are you at least older than 0 years old? So here's the really good example, right? So you can always just leave this as is. But what if someone gives you a negative number, you can just do nothing. But to generally be more precise in your science, you should always have an else statement. That should be if somehow something slips by your conditionals 1, 2, and 3, where all your other conditional check. You always want to use an else statement to catch whoever the rest is. This is the way to make sure, even though if you're sure. So if I say, oh, any number greater than 0, do this. Any number less than 0, do this. Or any number greater or equal to 0, do this. Anything less than 0, do this. I covered all my bases. But even in those cases, I generally recommend you putting an else statement in just so you're always sure that understand what's happening, right? So there should be no cases that triggers the else statement, but you can be like, write something else and be like, oh yeah, if this triggers, it's error, or like error should not occur, type of dealio. But in our case, let's say if you're less than 0, if you're not at least 0, you're probably a zombie. You'd be like, you can just do like a print, right? I can just do print. Wait, we don't serve the unalive here. Get out. Right, so now we built this nice, neat conditional block and chain. So I'm gonna first run it. So you can see now it's asking for my name. My name is Kev, and then like, would you like a drink? Yeah, I would love it. Oh well, let's say no first, right? If you say no, you can see when we program this as a nested loop. You can see if I say no, nothing else occurs. Well, maybe I can add something real quick. So I'm gonna do at the end. We can do once everything has been completed. Then maybe it says, "Have a nice day," and then we do this. And then we hit run. So now if I run through all this, you can do Kev. Would you like a drink? If I do no, the bot kind of just tells you, "Oh, have a nice day." But to build upon this, what we're gonna do is, let's say, give a name. My name is that's fine. Ket. My name is Ket. Would I like a drink? I would like to have a drink. Oh, okay. So we saw this problem where it's like there's maybe multiple versions of saying yes. What you can do is we talked about the object called list, right? There's a keyword in Python called in. So instead of just feeding it yes and checking only for yes, you can do if drink's answer is in, let's say a list of options, right? We can do yeah. We can do like just a few versions, right? Yeah. We can do like oops. We can do like yes, and then we can do like I don't know why, right? So there's a few versions of it. And what you might want to do is even because, for example, if I run this right now, I put in the name Kev. Would you like a drink? If I just put yeah, it fails because the strings are case sensitive. So what we generally recommend if you're using strings as your way to validating a Boolean condition, what you would do is you want to cast the string to either all uppercase or lowercase, and there's a method called upper or lower. So I would use the lower method. What this does is it'll take the input of lower, temporarily make it all lowercase, then checks it in the list. So you don't have to write both the uppercase version or in the mixed case, right? So technically, maybe you want to accept this as well, right? So Y lowercase, capital E, capital lowercase S. And what you would do in this case is you would just substitute this and just like, whoop, and then do enter. And if everything's lowercase, you wouldn't have this problem. So do my name is Kev. Would I like a drink? If I do yeah, that works. My age, let's say I'm let's see, what type of drink do we want? Let's say we're 21, right? So for 21 or older, it goes, oh, what alcohol do you want? And I can go, I don't know, beer, right? And since, okay, here, maybe we should add the line. So what we can do is after we get what they want, we can just be like, so the cool thing here is maybe if they want to drink, if they're old enough, right? Maybe what you want to do is actually enter. So what you can do is trigger it so it works like this. Actually, I'm gonna shrink this console a tad bit. So, right. So first, here's your if statement. Checks if they want to drink or not. If they do, ask for their age. Then checks the age. Then if they are 21 or older, ask if they want an alcoholic drink. If they're under 6 or older, ask if they want soda. If they're 0 or older, ask if they want apple juice or milk. And then if they're somehow younger than 0, like get out of here. You're on live. There's no place for you here. We don't serve you. And then what you can do is after that, because only one block from this block will run, you can add another thing menu here. So for instance, I might want to say print. Print. Here is your drink. Enjoy, right? So what this will do. Oops. What this will do is now it will print. Here's your drink and enjoy. After it prints out, oh yeah, so before it prints, have a nice day. So now we've played a bit with conditionals, right? We have seen how conditionals work, if, else if, blocks. We also have seen how placement of it matters, especially in Python, because it's a syntax-based language. Is there any questions from the chat before we proceed into our next amazing topic? Any questions? No questions? Okay, cool. So if you have done computer science before, you have seen generally if statements. Next thing we will look at after this is what we call looping. So looping essentially allows you to perform the same functions over and over until a condition is either met or when it's terminated by another cause. So for us, in our case, how we would do this is, so okay, now we ask for the drink, everything's great, amazing. A few more questions we're here. So for example, if I do 6, it won't trigger 21, it'll trigger the 6th place. So name is Kev. We like a drink. Yeah, I can do like capital YE, yeah. And then like, oh, I'm 6 years old. Let's see, what soda do you want? Give me a Coke. Here's your drink. Enjoy. Have a nice day. Whoa, amazing, wonderful. So now let's say I'm the bartender. I want to build out the menu. I want to make sure whatever drink they choose, we actually have. I want to add some input validation into it, and so on and so forth, which is all really important. But let's pretend I am now like a bartender, and I want to actually create the menu to be able to first, right? So let's say I want to go up here. I'm going to clean this up a tad bit. So the first thing I actually want to do is, before we welcome them, is maybe I want to build out the loud soda list, right? So what we would do here is we would write a loop. So let's say I want the user to be able to choose when they start the game how many soda or what kind of soda they want. You can first go. So maybe we can do something like print. We can do game setup. And after game setup print, you can do for. So there is 3 types of loops in Python. We have something called for I loops. I'm going to teach this first. Then we have something called for each loop. And then we have something called while loops. And I'm going to switch the for I for each loop because we'll find out actually soon. But we're going to switch these because this is how the order should generally go. I do have a quick question before we get continuing. How many people in chat, this is their first programming language in general? And how many people in chat, maybe this is not your first programming language, but this is your first time programming Python? I want to see how really in depth we want to be here. Probably going to go pretty in depth, but I'm trying to see what the audience space is currently looking like. That's fine. We're going to continue for now. So for each loop are essentially when you iterate through an actual thing and it takes. Oh, that's pretty funny. Yeah, Python's really easy to pick up, so that's pretty fun. JS is pretty interesting. Hello, do you hear me? I think I saw some like problems. Let's see if you can hear me still. Hello. Okay, cool. Looks like you can. Okay, cool. Yeah. So there's two types of for loops in Python. It's really just one, but we're gonna go over it. So the more common for loops you generally have seen is your actual probably for I loop, right? Because in a lot of programs we use this. So we will do for I in, and then in another language you would generally say, let's say for I in a list, or for I in XYZ. In Python, what we use the thing called range. In other languages, like for Java, you might see it's like for, and then you like set I, right, to equal something, I equals 0, and then you like set like a condition, for I start at 0, and then like I does not equal the conditions, I doesn't equal like 70 yet, you do I++, right? This is essentially what you would look like kind of in like Java and so on and so forth. Yeah, JavaScript is pretty cool. Oh, yeah, JavaScript is pretty cool. Maybe we'll teach JavaScript one day. But yeah, so this is like a loop we'll look at. Another for Python, the version of the same for loop would be for I in range. What range is? Range is a generator that generates something called generates a range of numbers. So let me write actually this out. So range takes 3 parameters, or 3 possible parameters. It takes the first one being the start, the second one being the end, the third one being the skip. So for example, if I do for I in range of 8, I should probably write this out. So for range, the only one that's required, the sole one that's you have to at least have is end. So if I do for I in range of 8, what this does is it will then loop 8 times. It will do whatever actions in here 8 separate times. So if I wanted to, let's say, in the beginning, ask so let's start with actually here. To make this make more sense, I'm going to start with actually do an input. So like num of possible drinks. And I can do this, hit equals, and then I can say, this. I want to get this from the user, right? So first I'm going to cast it to integers, then I'm going to do input, then I'm going to be like, ask the player, how many drinks do you want? I want to be at the shop. Cool. So we're gonna temporarily shelve for each loop. I'm gonna go with for I loop for now, and then we'll explain for each loop once we understand a bit more of the other concepts. And you can, and for just people who are here, understanding wise, the loops have like powers, right? So for each loop is the weakest of all the loops. It only solves, let's say, a subset of problem that's called the problem n. For I loops, we'll solve all problems in the subset n plus problems in subset j. So for I loops can solve problems in j and n. Well, for each loop, I only be able to solve problems in n. While loop is even more powerful than either for I loop or for each loop, being while loops can solve problems either in n or in j. But on top of that, while loop can also solve problems in, let's say, C. I don't know why I picked these numbers and made them really hard. But you can see the picture where I'm kind of drawing, which is the for each loop is the weakest of all the loops. It solves the most small subset of problem, and every for each loop solvable problem you can solve with a for I loop. Every for I loop solvable problem you can solve with a while loop, and so on and so forth. That means while loops can solve all problems that are from for I loops, as well as for each loops, as well as any additional problems that it wants to solve. Okay, cool. So how many drinks do you want to be at the shop? And then, for example, I do for I in range, and then you can put in the number here, right? So now you get the variable, you just gotta put in the number here. Let's loop it this number of times. So now maybe I want to make a list, right? So I want to make a list with a loop called maybe drink options. Now I have a list called drink options. I'm gonna put this as what we call those brackets. And then I'm gonna do for I range of possible drinks. We're gonna do drinks. So for the list we talked about there are ordered objects, order list, basically a collection of objects. So that means drinks to add to a order collection of objects, you have to let you use append. So what this is, it adds whatever the value here to the end of the list. And what we would do here is we would then append. What we want to append is we want to append whatever the user says, right? Because we want to ask the user for the number of possible drinks times, that many times what drink options they want to be on the menu. So we'll do append, and we'll do what drinks would you like? Question mark. Or like enter. Actually, the problem makes more sense if we do enter the drinks you would like. And then for this, what this is interesting. Okay, so first thing first, you open up, you ask them, oh, how many drinks would you like to be in the shop? After they answer, you created a drink options list that's empty, so you can then build out this list of drinks that can be in the shop. Then you say, let's loop as many times as the number of drinks the user wants to be in the shop. And each time we loop, we ask them, enter the drink you would like, and then we'll store it into the drink options list. So I'm going to run this, for example. Now we say game setup. How many drinks do you want in the shop? I want 9 drinks in the shop. Hello, welcome to the traffic. Ooh, something went wrong here. I think it didn't save before it ran is what went wrong, because I can't imagine it skips. Ooh, wait. Did I do something here? Let's see. So it does print game setup. It prints how many drinks do you want to be in the shop. It does do that. It casts as an int, and then it does drink options. And then for I'm a genius. I accidentally forgot to write input. So there was no user interaction. All it does, you just end up with a list of just this question. I'm going to do it like this. So now if I run this, you can say, how many drinks? I want 7 drinks in the shop. Enter the drinks you like. So let me say I want Coke. I want Pepsi. I want beer. I want A, B, C, D, E, whatever, right? So now you can see, actually, I should probably print this out for you. So let's print this out. So after we answer all that, I'm going to print out drink options. So let's go look at the list and what it looks like. So how many drinks do you want in the shop? Let's say we want 7 drinks in the shop. So what do drinks you want to be? We want to have beer. We want to have Coke. We want to have Pepsi. We want to have ginger, ginger, ale. I want to have Dr. Pepper. Well, I can't spell, whatever. I also want to have apple juice, GUIC. And enter the drink you would like. I would like, what else do I want? Let's say, orange juice, right? So now you can see that we have a list of beer, Coke, Pepsi, ginger ale, Dr. Pepper, apple juice, orange juice. And if I was to write this, the same thing in while loop works on conditionals. So unlike for loops where you give it a certain range that you're going to walk up to or work up to, while loops, you give it a condition. So I can say while, if I want to emanate exactly what the for loop does, we need something called counter. So I'm going to say the counter is equal to 0. So while the counter, which starts at 0, does not equal this could be problematic when you're developing, but we can still use this right now. So does not equal, let's say, the number of drinks the person asked. Oops, I meant to use a colon. We want to do drinks not append. But you want to be careful because generally for I loops, it's hard to enter what we call infinite loop, which is when you don't write your while loop with conditions, so it actually has the ability to terminate and just always will run. For loops, you generally won't be able to run into a situation like that because you gave it the condition for it to stop. For a while loop, it's generally off of a condition, so when that condition is never met, it'll just keep running. Because of that, why is it not happening? Oh, oops, I meant to, let's take this out because I commented out, so you can see if I comment out, it's not, it wouldn't be able to use it, so I'm going to uncomment it out. And then go back to the bottom. And you can see now, if I write this, it's now saying well thing. But if I run this as is right now, it will never stop, right? Because I said, well, the counter does not equal to the drink possibility. So I even a number of drinks. So even I say like 2 drinks, right? I'm gonna enter, and then you can see it keeps going on forever. And the reason is we never change what counter is. So we said, well, counter does not equal to the drink. Counter can never equal to the number of drinks. We never increased it or changed that up. So in our case, we want to increase it. So we want to do, here we can use one of the assignment operators we learned. Actually, this is nested one too many. It's going to be called counter. It's going to plus equals. So we want to add 1 to it. So that way it will progress forward and it eventually hit the drinks. Oh, I meant to do counter. If I run this, you'll see it goes, how many drinks we want? Let's say I want 2 drinks. And do apple and orange. And then now it will stop because now the condition of the while loop has been met and it's been terminated. Okay, cool. I think we're going to pause here. We're going to come back to this. Actually just fixed my camera. Hello everyone. So if there's any questions so far that I can help address? If not, we're probably going to table the rest of this. We'll put everything together. We learned about a conditional blocks. We learned about for loops, and we're going to probably put them all together next time and create a simple game, which kind of started today, modeling. I'm going to put together a simple game thing where we're going to have you guys code along with us, as well as taking input from the audience to build a really simple text game. I'm still thinking out what it is. It might be like a RPG game, and all you gotta do is follow along. I will explain what I'm doing as I go along. But yeah, we will see. It might be a simple RPG game. It might be a simple text-based adventure, or so on and so forth. Is there any questions from anyone? No questions? Everyone understands every single thing? If so, let me take a look at what's coming up. Give me like 1 second. Let me pull up. Bum bum bum. Okay, cool. So if there's no other questions, I could be honestly on anything. It could be on the topic we covered today. It could be in computer science. It could be on any single thing. Yes, there will be a recording. No, you're all good. You can also look at the recording later. There's also part 1 that goes a bit more stuff, but there's a lot of simple stuff. We'll probably review some of this next time before we continue and build out a simple, either I'm debating on RPG game, or it's going to be a simple story like, what's it called? What are they called? Storyline games or whatever, where you just kind of like go through a web novel. Maybe we'll let you make decisions and stuff. But yeah, we'll make a really simple game next time, taking the skills we've learned so far and putting them all together. But for everyone who's still around, please stick around for creating 2D games with Python or in Python with David that's actually occurring at 10 p.m. Eastern Standard Time, around half an hour from now. So maybe go take a break, take a walk, and then you guys can come back and learn some gaming skills. What is my domain in tech? That's a great question. My domain in tech is actually security. So I'm actually going to enjoy next Global Hack Week Live. If you don't know, next Global Hack Week is going to be Global Hack Week Security. I'm currently thinking of maybe hosting, maybe, this is a really big maybe hosting a CTF through Security Global Hack Week. But this is if I have the time between finals and everything single thing to get that out there, as well as between work, etc. But for sure, I'm going to do a lot of streams, hopefully for next Global Hack Week, because it is... Oh, actually, I'm a huge... actually, no. Yeah, I'll try to do a lot of streams for next week's Global Hack Week Security. I'm still trying to convince them to let me do lockpicking. It might not happen because certain things. But yeah, I'm probably going to do a stream maybe on ciphers, on like cryptography, maybe on some security things, some vulnerability stuff. It really just depends on what they allow me to do for security, because it's a pretty intense field. So maybe some malware analysis stuff or assembly. But yeah, security is generally my thing. It's my general domain in tech. Yeah, it is cool. It really depends if it actually happens or not, but we'll see. I will be trying to do a few cool things for the security ones for next Global Hack Week. Maybe we will write a simple cipher or make some security tools. Maybe we'll understand how hashing works, how passwords stored, some basic procedures. Like, there's so much to do. So I'm really looking forward for next Global Hack Week and really streaming for that. Yeah, for sure. I did flash my my whatever. Oops, that's a whole nother thing. I need to clean up these slides for next time I run this and build more into them too. Welcome to lecture 101. So there's stuff about me right there, as well as a lot of my social. If you want to reach out and have any questions, feel free to. But if there's no other questions, I do want to say stick around for Join Back Later, either one, for create 2D games with Python with David, or I think he should have done it in Python with David. At 10 p.m. Eastern Standard Time. Is there any other questions from anyone I can address? The slides, you can, if you watch the VODs, the slides will be on the VODs. Don't mind the mistakes, because I did not, these slides does have some mistakes in them, but you can watch the VODs and take a look at the slides. I don't think I'm going to be publishing the slides as of yet, because it's still a really work in progress. If I ever finish building out the master Python workshop slides, I will release them. But as of right now, it's not ready, and I don't really want to release them until it's really ready to be released to the general public. Yeah, it's really hard, because it's like, I realize this because like you already know it. Someone teaching Python, my biggest problem is I can't, it's not a full circle, right? So it's like, there's no really linear way of teaching Python either. It's not like, oh, you understand this, you understand this, you understand this, because most of the time this relates to that, that relates to that, and everything just kind of interrelates and interconnects, and it just makes it pretty difficult. So I'm trying to, as I'm slowly teaching it through these Global Hack Week workshops, is to refine the way I want to approach each topic in Python and how to make it all flow and connect so it works out great, right? So maybe I want to build enough in there, so maybe for like a 6-part or 5-part workshop where like you learn the basics, you learn the fundamentals, you learn the different conditional flows of code, execution flows. You then learn like functions, maybe a bit of object-oriented programming, a bit of classes, and then then it's just a really nice, easily flow between 5 things. But that's a work in progress. One day, if you come back for another Python workshop one day, maybe you'll get the whole entire experience when it's fully complete. But yeah, any other questions? If not, I will say thank you guys for showing up for tonight. It's been a wonderful time. Any suggestion for a college guy? Is this your traditional? Oh, what would you, if you could tell me one piece of wisdom, what would it be? Because I want to make sure I understand this question properly. I'll wait for it if that's what that question is. Well, I'll just answer actually. If the question is one piece of wisdom I can provide, I would say enjoy college as the experience, especially if you're going for undergrad. I wouldn't say it's okay if you want to rush the process, but I would say don't rush the process. Undergrad is a really unique experience. You only get once in your life. You'll never come back and be able to get the same experience. Even if you come back as undergrad when you're older, you'll no longer be in the same age group as college is there. So really enjoy your experience while you have it. Don't really rush it. There's no point in rushing in life. As well as don't be afraid to dive into any topic you are interested in, because it's never too late to go back and try something new. I've definitely talked to people and met people who have never been in CS and they're 30 and 40 years old and they decide to go back to school and for CS or learn on their own for CS. So it's never too late to make a change. So don't let fear hold you back, and don't be afraid of having regrets. It's never too late to make a shift or change. That's the biggest thing. So like two things. One, don't be afraid to explore and really dive into things. It's never too late to switch or pivot. And then two, enjoy your undergrad experience for what it's worth. There's no need to rush life. You can deal with everything outside of life after you come out. But I would say if financial is a different problem, that's a different situation. But yeah, I do think undergrad as an experience is valuable. Sometimes even more than the curriculum or lessons you get out of them, because a lot of this learning and education, especially nowadays, are over the internet. For example, at a Global Hack Week, I'm trying to build at least my platform workshop into like a college course level where you can like get through everything. But yeah, any other questions? If not, I would say get some rest for tonight. Please do come back and stick around for creating a 2D game with Python with David at 10 p.m. Eastern Standard Time. So we'll see you back here in 30 minutes. No, thank you guys for showing up. I really appreciate it. Hope you guys have a wonderful rest of your night. Take care.